So, good afternoon, everyone, once again. So, in the last class, what we have done, we studied about the transpose of a matrix. Yes or no? And how do we get the transpose? Just change the rows and columns of a matrix to get the transpose. Am I clear? So, make the first row as first column, second row as second column, and you get the transpose of the matrix you are looking for. Yes or no? So, today we will start with determinants. Then again we'll get back to matrix. Fine. So we have done everything about the transpose, and I have also made you aware that every matrix can be written as the sum of a symmetric and a skew symmetric matrix. Fine. Now let's start with determinants. Determinants. Okay. First of all, tell me one thing. A1x plus B1y equals to C1 and A2x plus B2y equals to C2. Can you solve these two equations for me? Can we solve these two equations? A1x plus B1y equals to C1 and A2x plus B2y equals to C2. So now if you try to solve them, the value of x that you get, and how do we solve them? Like multiply the first equation by B2, multiply the second equation by B1. So once you multiply them by B1 and B2 and you subtract, then y cancels out. Y cancels out, you get the value of x. So value of x will be B2 C1 minus C2 B1 upon A1 B2 minus A2 B1. Similarly, if you try to find the value of y you will be getting denominator same A1 B2 minus A2 B1. Numerator will be A1 C2 minus A2 C1. Now what did I do? I multiplied the first equation by A2 and second equation by A1, and then again I subtracted. Yes or no? Now there is a way to write these equations. What is the way? See, value of x you can see that is A1, A2, B1, B2. That is the denominator. How? Multiply first in downside order minus product in upside order. A1 B2 minus A2 B1. I'll talk about its numerator later on. Y is also having the same denominator, that is A1 A2 B1 B2. So this is again same A1 B2 minus A2 B1. Now in the numerator of x, delete the column of x, that is A1 A2, and instead replace C1 C2, and this is B1 B2. Now see C1 B2 minus C2 B1. Isn't it same C1 B2 minus C2 B1? Here, delete the column of y and replace C1 C2. So A1 A2 C1 C2. Now it is A1 C2 minus A2 C1. Am I clear? See everybody, please, at least any one of you can speak up. I cannot talk to walls for a pretty long time.
It's clear, sir.
And please, these chattings won't work for me. When I ask, have you got it? Please somebody reply, yes, you got it or you did not get it. So this is what we call a determinant of order 2. So from here, determinant is originated like if I have A, B, C, D. This is what we call, this is determinant of order 2, or you can write it 2 by 2. Because we will be dealing in square determinants only, no rectangular determinants. A, B, C, D, and its value will be AD minus BC. Am I correct? AD minus BC. Now, in the same manner, say you have three linear equations in three variables, A1x plus B1y plus C1z equals to D1, A2x plus B2y plus C2z equals to D2, and A3x plus B3y plus C3z equals to D3. Now in this case, if you try to find the solution, value of x will be delta 1 upon delta. Value of y will be delta 2 by delta. And value of z will be delta 3 by delta. Now, like in 2 by 2 case, delta is what? Delta is the determinant formed by the coefficients of x, y, and z. So it is A1, B1, C1, A2, P2, C2, A3, B3, C3. Now what is delta 1? Delta 1 is, now in case of delta 1, replace the column of x by D1, D2, D3. So D1, D2, D3, B1, B2, B3, C1, C2, C3. Note it down quickly. Similarly, delta 2 you can figure out. Replace the column of y. So A1, A2, A3, D1, D2, D3, C1, C2, C3. And what is delta 3? It is A1, A2, A3, B1, B2, B3, D1, D2, D3. Have I made my point clear?
Yes, sir.
So this is how we start with the determinant. Now they all are what? They are determinant of order 3 by 3. Determinant of order 3 by 3. Fine. Copied. Now, let's talk about the minors. Minors of an element of a determinant. Minors of an element of a determinant. Now say you have a determinant D as A11, A12, A13, A21, A22, A23, A31, A32, A33. Fine. Say you have a determinant this. Now, minor with respect to an element is basically minor with respect to Aij is expressed as Mij and can be obtained, not can be obtained, and minor with respect to Aij is expressed as Mij and is the remaining determinant after deleting ith row and jth column, and is the remaining determinant after deleting ith row and jth column. Like if I talk about minor with respect to M23. So while talking about the minor with respect to M23, what you will do? Minor with respect to this element means delete this row and delete this column. So what you are left with? A11, A12, A31, A32. Yes or no? So that is value of determinant A11, A12, A31, A32. So that is A11, A32 minus A31, A12. Is it okay? Similarly, if I talk about minor with respect to 3 to say, means this element, so delete its row, delete its column. So A11, A21, A13, A23. A11, A21, A13, A23. That is A11, A23 minus A21, A13. Understood? So this is how we find the minor with respect to an element. So in case it is a 2 by 2 matrix, like you have a matrix determinant D as A, B, C, D. So minor with respect to A11 means M11. So M11 means minor with respect to this. So delete this, but you are left with only D. So minor is D. If I talk about M12 means C. If I talk about M21 means B. And if I talk about M22 means with respect to this, delete this. So what you are left with? A. So M22 is A. So in case of a 2 by 2 matrix, this is how we find minors. And in case of 3 by 3, this is how we find the minors. Is it okay?
Yes, sir.
Well, now there comes a point, cofactors. So cofactor with respect to Aij is expressed as Cij, and it is minus 1 raised to the power I plus j into Mij. So Cij is minus 1 raised to the power I plus j into Mij. Is it fine? So there is nothing much difference. The only thing is, while calculating cofactor, if the sum of suffix is odd, it is negative of minor. If sum of suffix is even, it is equal to minor. Like C11 is M11, but C12 is minus of M12. C13 is M13. That means in case of a 3 by 3 matrix, say A11, A12, A13, A21, A22, A23, A31, A32, and A33. So minor with respect to these 4 elements. will be negative of their cofactor, or I should say cofactor with respect to these four elements will be negative of the minor. Yes or no? Means Cij plus Mij is 0 if I plus j is odd, and Cij is Mij if I plus j is even. Is it okay? So now calculating minor, calculating cofactor is an easy thing for you. Fine. Write down a question. In the determinant, one, 2, minus 1, 4, 0, 3, minus 2, 1, 1. Find C12, M23, C33, M21, and M23 and M13. Yes. Find the value of all of them. Quickly. Yeah, the question is raised. Can somebody tell me the question again? Can someone please repeat the question?
1, 2, minus 1,
1, 2, minus 1,
403,
403,
minus 2, 1, 1.
minus 2, 1, 1. Thank you, Abhishek. And
Find
find to what?
C1, find C12, M23,
M23,
C33,
C33,
M21,
M21,
M23.
M23. M23 already calculated. In case of that, let's find C1, 1. Yes, please quickly tell me the values.
Sir, C12 is minus 7.
C12 is minus 7. Very good. Others? What is M23? Anybody?
Eight, sir. M23 is 8.
Sorry?
8, sir.
M23 is 8. No. M23 is minor with respect to this element. So it is 2 plus 2, 4.
Ah, sir. 4, sir.
C33. Quickly. C33 is cofactor with respect to this. So 0 minus 8. And cofactor is equal to minor in this case. So answer is minus 8. Now M21. M21 minor with respect to 21. So minor with respect to this. This is gone. This is gone. This is again 2 plus 2, 4. And extra minus that we will imply. So it is minus 4. Meaning It is 4 only. We are calculating minor, not the cofactor. And C11 is cofactor with respect to this. C11 is equal to M11, so that would be minus 6. Is everybody okay with these things?
Sir, I think C12 is wrong.
C12 is, this is gone, 4 plus 3, 7. And extra minus we will imply, yes, minus 7 is correct. Abhishek, are you saying something?
So the question was -211, sir. Last
So
row.
whatever you have written, you just calculate accordingly.
Okay, sir.
Fine. Now, एक और question लिखो. Find the value of determinant a plus 1, a minus 2, a plus 2, a minus 1. Yes, quickly. Two by two determinant value, you know how to calculate.
Sir, 3.
Very good. Answer is 3. Anybody who want my assistance in this? Value will be what? A plus 1, a minus 1, minus of a plus 2, a minus 2. So it is a square minus 1 minus a square minus 4. So it is minus 1 plus 4. Answer is 3. Very good. Write down another question. Find the value of determinant 1 plus cos theta, sin theta, 1 minus cos theta is. Quickly. Sorry?
0, sir.
0. Very simple. All right.
0.
Thank you so much, guys. I just expect this kind of response from you, nothing else. And I don't expect too much. Just keep on responding little things. Now, write down a point, value of a determinant. Value of a determinant. See, in case of 2 by 2, you have already calculated the value. But how do we get the value in case of a 3 by 3 determinant? If elements of any row or any column, if elements of any row or any column be multiplied by respective cofactors, if elements of any row or any column be multiplied by respective cofactors and added, we get the value of the determinant. Got it? Means elements of any row be multiplied by the respective cofactors and added, we get the value of the determinant. So in such cases, generally we prefer the row or the column where we have maximum number of zeros. Say you have a determinant A11, A12, A13, A21, A22, A23, A31, A32, A33. Now its value is what? See, multiply the first row by respective cofactors. So A11 C11 plus A12 C12 plus A13 C13. This is the value of the determinant, one way to get it. Or multiply the second row A21 C21 plus A22 C22 plus A23 C23, or multiply with the say first column A11 C11 plus A21 C21 plus A31 C31 and so on so forth. This is the value of the determinant. Am I correct? Write down quickly. This is the value of the determinant. Write down a simple point. If elements of any row or any column, the elements of any row be multiplied by respective elements of any other row, then we get 0. If elements of any row be multiplied by the respective cofactors of any other row or column, we get the value 0. Am I clear? So now the 2 points came into the picture. If elements of any row be multiplied by the respective cofactors, elements of any row be multiplied by the respective cofactors of same row, you get the value of determinant. But if elements of any row be multiplied by the respective cofactors of any other row, be multiplied by the respective cofactors of any other row, then what do you get? Then we get 0. Fine. Let's write down a simple question. Find the value of determinant 1, 2, 3 minus 4, 3, 6, 2 minus 7, 9. Yes, quickly. Tell me the value. One, 2, 3 minus 4, 3, 6, 2 minus 7, 9. Quickly tell me the value of the determinant. Yes, anybody value of the determinant, please? $83 is not the correct answer, Anush. Anybody else?
So is it 54?
Sorry?
Is it 54?
No. Anybody else? Quickly, quickly. See, if I expand along the first row,
Sir, 183.
sorry?
183.
No. Anybody else?
Sir, 69.
No. No, Srinidhi, not 99. It is one time. See, 27 plus 42. What did I do? One time, its cofactor will be 27 plus 42. Then minus 2. I applied minus before it because its cofactor will come with the extra negative sign. Now this is gone, this is gone. Minus 36 minus 12. Yes or no? Minus 36 minus 12. Then plus 3 times. This is gone, this is gone. This is 28 minus 6. 28 minus 6. So it is 27 and 42. 7 and 2, 9. 4 and 2, 6. 69 minus 2 into, it will become plus 48 plus, it is 22 into 3, 66. So this comes out to be 69 plus 66 plus 96. Correct? So 6 and 6, 12, 12 plus 9, 21, 1. 6, 6, 6, 18 plus 3, 20, 6, 6, 9. 21 and 3, 6 and 6, 12, 12 and 9, 21, 2 carry में, 6 and 6, 20, 23. Answer is 231. See how simple it is. What
Yes,
you
sir.
guys are doing. Tell me. Anyways, now let's talk about applications of determinant. Applications of determinant. So now we'll see where we use these applications mostly. First is, tell me, anywhere, where all do you remember? Where have we used applications? Wherever we used determinants, what all do you remember? Yes, anybody? If you have a vector A as, say, A1 I cap plus A2 J cap plus A3 K cap, and you have a vector B as B1 I cap plus B2 J cap plus B3 K cap. Now, if you try to calculate A cross B, then it will be determinant I cap, J cap, K cap, A1, A2, A3, B1, B2, B3. Correct? So it is I cap, J cap, K cap, A1, A2, A3, B1, B2, and B3. Is it okay?
Yes, sir.
Second application that you must be knowing, area of triangle with vertices, area of triangle with vertices x1, y1, x2, y2, and x3, y3. So area is half of determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. And mod of this, why do we apply mod? Because area is always positive. Or in this case, we also show that 3 points x1, y1, x2, y2, and x3, y3 are collinear if area of the triangle made by them is 0. Means x1, y1, 1, x2, y2, 1, x3, y3, 1. This goes 0. Tell me, is it okay? Third application that you should remember, three lines a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equals to 0, and a3x plus b3y plus c3 equals to 0 are concurrent. Concurrent means passing through same point. Are concurrent if determinant a1, b1, c1, a2, b2, c2, a3, b3, c3. This goes 0. So if the value of this determinant goes 0, that means these three lines will be concurrent. Concurrent means they will be passing through the same point. Make a note quickly. Now, fourth point. A second degree general equation in two variables a second degree general equation in two variables, that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. A second degree general equation in two variables
Unknown caller.
So a second degree general equation in two variables, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0 is capable of resolution in two linear factors if determinant A, B, C, F, G, H, F, G, H is equals to 0. If determinant A, B, C, F, G, H, F, G, H equals to 0. Is it okay? So a second degree general equation in two variables is capable of resolution into two linear factors. Means this second degree general equation can be resolved into two lines if this quantity goes 0. So these are certain applications of determinant. One moment. So those were the applications of determinant. Now we will go with a few questions. Find the area of the triangle with vertices as 1, 2, 4, minus 1 and 3, 6. Yes, please. Tell me the answer. 1, 2, 4, minus 1 and 3, 6. Yes, quickly tell me area of the triangle. Half of determinant 1, 2, 1, 4, minus 1, 1, 3, 6, 1. Yes or no?
Yes, sir.
So this is going to be the area. Have you calculated?
Sir, 18.
Sorry?
18.
18. Now let me do it. Half of 1 time minus 1 minus 6 minus 7 minus 2 times 4 minus 3 1 plus 1 time 24 and 3 27. This should be the answer. That is half of 27 minus 9. That is 18. Answer is 9 square units. Yes or no? Is it okay?
Yes, sir.
Write down another question. Show that points A comma B plus C, B comma C plus A, and C comma A plus B are collinear. So if these points are collinear, that means area of triangle formed by them. You have to show it what? What should be the area of triangle formed by them? 0. For
Zero.
the
Zero.
points to be collinear. Now, how do we do it?
एक मिनट रख लो.
Yes, what should be the area of triangle? Now it will be determinant A, B plus C 1, B, C plus A 1, and C, A plus B 1. You just calculate the value of this determinant. So that would be A times C minus B minus B times C minus A plus C times B minus A. Now if I do it, AC minus AB minus BC plus AB plus BC minus AC. So everything cancels, this value goes 0. So if this value goes 0, that means points are collinear. Am I correct? Is it okay, everybody?
Yes, sir.
So let's keep up to this point in this class. So what we have done today, a 2 by 2 determinant, what it is? So these are the 2 by 2 determinants. Then we have covered to get the solutions of a 3 by 3 determinant. And using this, x is delta 1 upon delta, y is delta 2 upon delta, and z is delta 3 by delta. Then minors of the elements, then cofactors, then value of the determinant. So if we multiply elements of any row with the respective cofactors and we add them, we get the value of determinant. But if we multiply the elements of any row with the cofactors of any other row, what do we get? We get 0. All right. Then application of determinants में where we generally use it, cross product, area of triangle, collinearity of 3 points, and condition for concurrency of 3 points. And then we use it a second degree general equation when it can be resolution into 2 linear factors. Is it okay?
Yes, sir.
So that is all for today. The topic is done. So in the next class, we will be starting with the properties of determinant, which is a very crucial and important topic. So you cannot afford to miss that topic. All right. So that would
Yes,
be
sir.
all from my side today. Thank you so much. Thank you, guys.
Sir.